Well, welcome back to the start of the third quarter here. We're going to have a nice little warm-up with some polynomials. So in our first example here, if f of 2 equals 24, find b. And our polynomial here is f of x equals 3x cubed plus bx squared minus 18x plus 8. So hopefully you're feeling pretty good about this question. We've evaluated functions ever since 9th grade. Hopefully this is pretty straightforward. Remember, this is really read f of x. So I'm replacing the x with the number 2, and I'm setting the final equation equal to 24. So I'm replacing all my x's with 2. So f of 2 is equal to 3 times 2 cubed plus b times 2 squared minus 18 times 2 plus 8. Now, take note here, we already know what f of 2 is. They told us f of 2 equals 24. So 24 equals. All right, let's watch our math here. 2 cubed is 8. 8 times 3 is 24. 2 squared is 4, so plus 4b. Minus 8 times 2 is 16, so 36 plus 8. So I'm going to take that 24, I'm going to have my 24, my negative 36, and my 8. And I think that's going to get me a negative 4 plus 4b. Easy enough. Add that 4 over, so 28 equals 4b. Divide by that 4, and b equals 7. So first part, hopefully very straightforward. We just solved for b. So I'm going to go ahead and rewrite that new function for myself. My new function, f of x, is equal to 3x cubed plus 7x squared minus 18x plus 8. All right, let's add a second part to this. Let's say we now know that f of 1 equals 0. What does that tell us? If I now substitute 1 in, this function is going to equal 0. Well, that tells me, hopefully you're saying it in your head already, that x equals 1 is a factor, or is a root, I should say. Okay, so if x equals 1 is a root, your gut should be immediately saying, what is a factor? Well, and again, if x equals 1, I would just subtract that 1 over, and I now know therefore that x minus 1 is a factor. Okay, I would say that's something we were pretty good at earlier on. Well, if x minus 1 is a factor, I can figure out all the zeros to this polynomial. All I have to do is take this and divide by the factor of x minus 1. All right, so let's go ahead and do a little long division. All right, I'm going to let you pause it, you work out your long division, and we'll see if we get the same thing. So good luck. So go ahead and check my work, see if you got the same thing. I got a remainder of 0, which tells me these are the two factors of this polynomial. So I'm going to go ahead and write that down for myself. That is a factor, and so is x minus 1. Now, if I set those equal to 0, I can easily go get the roots of this polynomial. I'm just going to refactor this term. I already know that one's x minus 1. So I know it's got to be 3x and x. Those are my only options that multiply to 3. So here I can use 4 and 2, or I can use 8 and 1. And remember, my outsides and my insides have to total a 10x. This negative is telling me that I want my signs to be different. So I'm going to go with a 4 here. That's going to get me a 12, and a 2 here. That can get me a positive 10 if this one's a positive and this one's a negative. So now I can solve, and I can say one root is x equals, I'm just going to set this equal to 0, add over the 2, divide by 3, so 2/3. X equals negative 4, and x equals 1. So there was a ton of information we got just by them telling us f of 1 equals 0. So again, I want to kind of slow down and talk about what we just did. We started out by evaluating a simple function, plugging in an x and setting it equal to y to get the b value. Okay? After we found that b value, we rewrote our new function, and we said, okay, I'm going to give you another piece of information. F of 1 equals 0. That means you know a factor. Okay? X equals 1 is a root, therefore x minus 1 must be a factor. Since that's a factor, I can easily divide to get the remaining factors. Therefore, x minus 1 times this quantity is how I would factor this polynomial. And if I factor that even further, I'll get the zeros of the polynomial. Now we talked about graphing these. We made a quick sign chart for ourselves. Okay, we said put them in order from least to greatest. So -4, 2/3, and 1. And we basically said we just need to know whether the function is positive or negative. And you can pick any number you want here. So let's say I want to plug in a 2. All I care about is whether this is positive or negative, and it's easiest to plug in this factored form. Okay, so I'm first going to plug it in here. 3 times 2 is 6, minus 2 is a positive 4. 2 plus 4 is a positive. 2 minus 1 is a positive. And a positive times a positive times a positive is a positive. I'm going to pick somebody over here, maybe like -5. 3 times -5 is -15, minus 2 is a negative. -5 plus 4 is a negative. -5 minus 1 is a negative. And a negative times a negative times a negative is a negative. Then I'll test somebody here. Maybe I'll test a 0 in this section. Anybody between a negative and a positive. So 0 minus 2 is a negative. 0 plus 4 is a positive. 0 minus 1 is a negative. And if I multiply those symbols together, I get a positive. Okay, and then again, I would pick a number in between there. And I think we'll get a negative when we do that as well. Now, based off this sign chart, we can easily sketch this function. We'll start with our zeros of -4, 2/3, and 1. And we know that's where the function hits 0. Those are our only zeros. Okay, a negative just means the graph is below. A positive means above. A negative means below. And again, a positive means above. Now we can say, okay, we even know a little more about this. This degree polynomial is definitely odd because the function starts low and ends high, starts and ends in opposite direction. So I know it's an odd degree, not symmetry, just an odd degree polynomial. And so there's a little bit of practice with that one. Our second example for the night is to solve this system. Now, I'm a little nervous that some of us don't understand what this question is even asking. A system just means you have more than one equation. So you'll notice they gave us 2 equations. And basically, when you solve a system, anytime you have 2 equations, all you're looking to see is where they intersect. Okay, let's jot that down. That's all they're asking. That's what a solution to a system is. Just where do these functions intersect? Okay, now, you should kind of have a ballpark in your head of the equation they're giving you. For example, y equals x plus 1. When you graph that, what is that going to make? Well, hopefully you understand that that's linear. That's just a line. Okay, there's no square terms, it's not a parabola, it's a linear function. It's in the form of mx plus b. Now how about this guy? X squared plus y squared equals 1. Hopefully you're screaming circle out loud at home there. So the question really is, when they say solve the system, in this particular problem, we're going to say how many times can a line and a circle meet and what are they? So picture a circle and a line. Do they have to touch? Certainly not. Could they just touch once? Sure, we call that tangent. Could it touch more than once? Yes, it could go right through. But I don't think you could possibly draw it that it has more than 2 solutions. Okay, now, we talked about substitution and elimination. And by golly, you cannot solve this with elimination. You only solve elimination if you have linear, okay, if 2 linears, like a 3x3 system that we've done. If you have a linear and a nonlinear, you've got to make a note here, you're going substitution. Okay, now, some of us like to make this really hard and pick like the worst possible variable to solve for. Half the time, guys, they say y equals, so your one is already done for you. You just have to substitute it into the other one. If you really wanted to solve for x, could you? Yeah, but why would you? It already says y equals. Okay, so I'm literally going to take whatever this y is equal to and substitute it into this y very carefully. So x squared plus, substitute with parentheses, x plus 1 squared equals 1. Okay, order of operations, say we have to multiply this out or FOIL. So hopefully you can FOIL in your head. X squared plus 1x is plus 2x plus 1 equals 1. Put those together, that's 2x squared plus 2x. I'm going to subtract that 1 over, those eliminate, equals 0. Okay, now, the easiest type of factoring in the world. Anytime you have two terms, guys, you're saying what in your head? Okay, some people keep trying to factor this with trinomials, but two terms, you always want to look for a GCF. You could easily pull out a 2x. And remember, you're just dividing 2x. So when I divide those 2's cancel, that leaves me with an x. There's a plus sign. 2x divided by 2x is not nothing. It is 1. And then we'll just tee it up and solve. I'm going to set both sides equal to 0. Okay, by no means am I rejecting any answers. Here I get x equals 0. Here I get x equals negative 1. Now again, guys, this is not done. Remember, we just said a solution is these points where two things intersect. Now clearly I'm getting two x values, which means it's intersecting twice. Okay, it's not missing the graph, it's not tangent to the graph. We are intersecting these functions twice, which means every x has a y. So if x equals 0, you can pick any equation you want to substitute it in. I'm going to pick the easy one, which is y equals x plus 1. And if x equals 0, 0 plus 1 is 1, y equals 1. So that point of intersection is 0, 1. And if x equals negative 1 plus 1, y equals 0. So this point of intersection is negative 1, 0. So I can't stress enough, a solution are points of intersection. And in this case, because I got two x values, I know the circle and line are intersecting twice. All right, well, we look forward to some great practice tomorrow. Have a good night.